ALHS Online Learning, Math 9, Extra Practice 2.4. Number 1. Write each product as a single power. When you multiply two or more powers with the same base, you can write them as a single power. It helps to think about it as repeated multiplication. If you have 5 to the power of 4 times 5 to the power of 2, you can rewrite this as repeated multiplication. 5 to the power of 2 times 5 to the power of 4 becomes 5 times 5 times 5 times 5 times 5 times 5. And you can see how it's broken up with the first power right here being broken up right here, and the second power right here being broken up right here. You can see that we have 5 multiplied by itself 6 times. So now you can rewrite it as a single power, which would be 5 to the power of 6. The easiest way to solve this is to add the exponents. So 5 to the power of 4 times 5 to the power of 2 equals 5 with a power of 4 plus 2, which gives us 5 to the power of 6. This is an example of the law of the product of powers. Now, number 2, write each quotient as a single power. When you divide two or more powers with the same base, you can write them as a single power. It helps to think about it as repeated multiplication as well. If you have 8 to the power of 7 divided by 8 to the power of 4, you can rewrite this in fraction form. Now we can use repeated multiplication. As you can see, 8 to the power of 7 we have right here, with 8 multiplied by itself 7 times. Then on the bottom we have 8 to the power of 4. In fraction form, you have the 8's on the numerator canceled out by the 8's in the denominator. So these here, as we can see, are scratched out, 4 for each of these. So this one canceled out that one, this one was canceled out by that one, this one was canceled out by that one, this one was canceled out by that one, and that leaves you with just 8 times 8 times 8. You can see that we have 8 multiplied by itself 3 times, so then we can rewrite this as the single power, 8 to the power of 3. The easiest way to solve this is to subtract the exponents. So 8 to the power of 7 divided by 8 to the power of 4 would give us 8 with exponents 7 take away 4, which gives us the final, the single power of 8 to the power of 3. So that last one was an example of exponent law for a quotient of powers. For this one here, number 3, we're going to express these as single powers. When you multiply and divide 3 or more powers with the same base, you can rewrite them as a single power. So if you have 3 to the power of 2 times 3 to the power of 4 divided by 3 to the power of 3, you go from left to right. So first we start with these two right here, which would give us 3 with the power of 2 plus 4, which leaves us with 3 to the power of 6 right here. So then 3 to the power of 6 gets divided by 3 to the power of 3, which gives us 3 with an exponent of 6 take away 3, which gives us our single power of 3 to the power of 3. Simplify, then evaluate. When you multiply and divide, as well as adding or subtracting 3 or more powers with the same base, you have to use the exponent law to simplify the expression before you can evaluate it into standard form. There might also be a curveball thrown at you when there is terms in the expression that is not a power but just a number. If you have 3 to the power of 0 take away 3 to the power of 2 times 3 plus 3 to the power of 4, what you need to remember is that any number written in standard form, such as 3, so this 3 right here, can be rewritten as a power with a base of 3 and an exponent of 1. So this really equals this. And just so that you understand, this here was really 3 to the power of 1. Even though there is no exponent of 1 right here, it can be rewritten with that. So if you see this little curveball thrown at you, remember, just put 1 in as our exponent. Now you can use the exponent laws to solve for multiplication. So here we have 3 to the power of 2 times 3 to the power of 1. And this will give us 3 with an exponent of 2 plus 1, which gives us the single power of 3 to the power of 3. And now we have no more multiplication or division. Now we need to turn each power into standard form and then solve. So 3 to the power of 0 becomes 1, because any number to the power of 0 equals 1. 3 to the power of 3 is 27, and 3 to the power of 4 is 81. And now we use order of operations to solve the rest. We have 1 take away 27 would give us negative 26 plus 81. So negative 26 plus 81 is going to equal 55. And 55 is what this expression is evaluated down into standard form. Now number 5, simplify then evaluate again. When you simplify and evaluate powers with some of the same bases, but with different bases as well, it is important to follow the order of operations and remember that the exponent laws do not work with powers that do not have the same base. It can be even more difficult if you are given the expression in fraction form. If you have 4 to the power of 5 divided by 4 to the power of 4 plus 6 to the power of 3 times 6 to the power of 2 over 3 to the power of 5, you need to remember that each fraction is really a division that will get solved at some point. First, let's use the exponent laws to simplify the expression. Here I have this set of powers that have the same base, and I have another set of powers that have the same base that are using division and multiplication. So I'm going to simplify them. First, we have 4 with an exponent of 5 take away 4. Next, over here, we have 6 with an exponent of 3 plus 2. We solve our exponents, and that gives us 4 to the power of 1 plus 6 to the power of 5 over 3 to the power of 5. These two terms right here do not have the same base, as you can see. It's a 6 and it's a 3. At this point, we have the option to rewrite the expression to a division instead of a fraction. So we can change this fraction right here into a division and keep the statement and keep everything the same. So to continue with simplifying and evaluate, when we have 4 to the power of 1 plus 6 to the power of 5 over 3 to the power of 5, we can turn this into a division statement by just changing this fraction into a division right here. And we still have 4 to the power of 1 plus 6 to the power of 5 divided by 3 to the power of 5. Now we need to turn each of the powers into standard form and then solve. So we have 4 to the power of 1 plus 6 to the power of 5 divided by 3 to the power of 5. And when they get turned into standard form, we're left with 4 plus 7,776 divided by 243. First, I do this division. So 7,776 divided by 243 equals 32. And I'm left with 4 plus 32. So 4 plus 32 equals 36. So this expression equals 36. Next, we're going to talk about what happens when we write each relationship as a product of powers or a quotient of powers. If you were given a written statement, 1,000 is 10 times as great as 100. When you're looking at a relation in writing, it is best to think of it in equation form. So as an example, we can rewrite it as 1,000 equals 10 times 100. We start with our 1,000, and we can put that right here before the equal sign. So whatever number we have right here, we can just write that and then put our equal sign in is. It's telling us that it's 10 times. So this is where we get 10 times from, 10 and our multiplication sign. And it's 10 times as great as 100, and that's where we get our 100 from. So we can rewrite this in equation form. This will make it easier to write this whole statement into a single powers to make sure that it's true. So we can turn each of those into powers of 10. So 1,000 is 10 to the power of 3, 10 is 10 to the power of 1, and 100 is 10 to the power of 2. We can combine both of these here using the exponent law for the product of powers, which gives us 10 with an exponent of 1 plus 2. When we add that together, we have 10 to the power of 3 equals 10 to the power of 3, and that proves that 1,000 is 10 times as great as 100. These can be a little confusing, so sometimes it's better when you can see it written out this way. Next, we're going to talk about writing a relationship as a product of powers or a product of quotients. And this time is if you have something like tenths, hundredths, millionths, billionths, thousandths, things like that. If you have a relation in writing that has tenths, hundredths, thousandths, millionths, billionths, etc., it implies division. Equals division. So think of this as division. As an example, 1,000 is 1/1,000,000th of a billion. Notice that what we can do is we can still turn this into an equation. Notice that even though 1/1,000,000th is earlier, it still comes at the end of the equation. So 1,000 we have right here is equal to 1,000,000,000 and since this is in millionths, we see the TH right here, millionths, 1 billion divided by 1 million. So we have 1 million right here, 1 billion right here. That's where we're getting these particular numbers from. And because we have the TH, millionth, that is implying division right here. So we now have this in an equation form. And now that we have this in equation form, we can turn this into powers of 10. So 1,000 is 10 to the power of 3, 1 billion is 10 to the power of 9, and 1 million is 10 to the power of 6. we use the quotient law, and we can see right down here that we have 9 take away 6 because it was division. 9 take away 6 because it was division. And that proves that 10 to the power 3 is equal to 10 to the power 3. So because this is equal, we can really say that this statement is true, that 1,000 is a millionth of a billion. Now, if you need to identify and then correct an error, there's a few simple things you can look for. So for these questions, it can be a bit of a trial and error. It is helpful to know that some common errors people make when solving these types of questions can be A, the exponents are multiplied instead of added. Sometimes you will multiply exponents. So if you have something like 3 to the power of 2, that looks like a 1, 3 to the power of 2 times 3 to the power of 3. In this case, you are going to add those exponents. 2 plus 3, and give yourself 3 to the power of 5. However, some people might make a mistake and multiply these numbers and wind up with 3 to the power of 6, which would be the wrong answer. So that's one mistake some people can make. As well, sometimes they multiply the bases. So in this particular case, you might go 3 times 3 and give yourself 9 to the power of 2 plus 3, which is not correct either. You leave the bases the same, so it's just 3, and you don't do anything with the bases, you just add the exponents. Another common mistake can be the exponent was subtracted from the sum of an exponent instead of added. So sometimes if you have a division, you might accidentally add the exponents instead of subtracting them the way you're supposed to, and vice versa. If you have multiplication, you might accidentally subtract the exponents. So just make sure when you have powers with the same base that are being multiplied, you always add the exponents. And when you have powers with the same base when you are dividing, you subtract the exponents. All right, great. I hope that was helpful for everybody.